Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 6 Learning Target 5 notes. We're going to be talking about compound interest. So before we talk about compound interest, I just want to briefly review what we did with exponential growth. So let's do this problem. In 1982, there were 84,105 females in high school sports. Since then, the number has increased at an average of 9.4% per year. So we're supposed to write the equation that represents the number of females participating since 1971. So let's start that out. So notice it says that it's increasing. So we know we're going to use exponential growth. So then our starting value was 84,105. Then we're going to do 1 plus our rate. Well, our rate is in a percent, so we need to make sure we convert it to a decimal. So I'm moving that decimal place over so I get 0.094. And that's going to be raised to the t power because we don't know how much time is passing. Well, I actually need to add both of those. So then I get 84,105 times 1.094 raised to the t power. So now I need to figure out how many women there were in 2005. So what I'm going to do is I am going to take, and I'm going to do 2005 minus 1982, and that's going to be equal to, when we subtract those, 23. So 23 years have passed, so that's what we're going to plug in for our t right there. So we're going to do 84,105 times, oops, I actually should have added those up here, that was my mistake, 1.094. And then we're going to raise that to the 23rd power. So when we raise that to the 23rd power, again, you should be checking this along with me. You get 64,079.7. Well, this number right here is 5 or greater, so we need to round this one up. Well, when you round 9 up, you actually have to round the number after it as well. So this is going to become 66,000 or 664,080. So 79, when you round it up, rounds to 80. And we want to say females because that's how many females were participating in high school sports after those 23 years. Now let's talk about compound interest. So compound interest is A is equal to P times 1 plus R divided by N raised to the NT. So A is the amount. That's the amount that we're predicting. P is the starting amount, how much money. So this is talking about putting money into the bank. So when you put money in the bank, you gain interest on it, which means you make money for keeping it in the bank. R is the rate that you're giving when you put it in the bank. N is the number of times it's compounded per year. And T is the number of years. So you're going to use the compound interest formula if in the problem it says the word compounded. If it says it's compounded annually, compounded monthly, whatever it is, if you see that word compounded, that means you need to use that compound interest formula. So make sure you have that written down because it is a tricky one to remember. So let's go ahead and let's take a look at this first one. Maria's parents invested $14,000. So I'm going to start by assigning my values. Well, they're starting with $14,000 at 6% per year. So that's my rate, but I want to put my rate as a decimal. So it's 6. So what I'm going to do is I'm going to convert it into a decimal. So my rate is 0.06. Compounded monthly. So I need to think, okay, if it's monthly, how many times a year is that? Well, there's 12 months in a year, so that means the number of times per year is 12. How many will there be in 10 years? Well, 10 years is going to represent my t. So these problems are a lot easier if you just go through and assign your variables as you go. So let's go ahead and let's put this in. So we're starting with $14,000. So this is going to give us our amount after 10 years. Then we're taking 1 plus, now we're going to take our rate, but we want it as a decimal, not as a percent, divided by the number of times per year, which is 12, raised to the power of the number of times per year times the number of years. Now here's a trick with simplifying that I want you guys to do. Before you punch everything in your calculator, I want you to simplify that exponent down first. So you get 14,000 and then 1 plus 0.06 divided by 12. You do not have to simplify this out if you don't want to. It actually keeps it more accurate if you don't simplify it out in advance. Then we're going to do 12 times 10, which is 120. Now this entire thing right here, you can plug into your calculator. So I want you to pause the video and plug it into your calculator so you make sure you get the right answer. And when you do that, you get 25,471.554. Well, when we're talking about money, we only want to have 2 decimal points. So we need to take a look at this one. Since it's under 5, this number is going to stay the same when we round. So it's $25,471.55. So if you put in $14,000 into the bank under those contingencies, after 10 years, that's how much money will be in your bank account. Next, let's take a look at number 3. So it says determine the amount of investment if $300, okay, that's our starting amount, that's our C, is invested at a rate of 0.35. Okay, well, that's our rate, so we're going to take and we're going to convert it immediately into a decimal. So we get 0.035. There's that compounded. That's how I know I need to use the compound interest formula. Semi-annually, that gives me that my N is equal to 2 because it's semi means twice. So twice a year. For 22 years, well, that means that my T is 22. So now I'm going to go ahead and I'm going to plug it into that formula. So my amount is equal to the fact that I'm starting with $300 times 1 plus my rate, which is 0.035, divided by my number of times per year, which is 2, raised to the number of times per year times the number of years. Now remember, before you simplify everything out, you need to simplify the exponent first. So then you get 300 times 1 plus 0.035 divided by 2, raised to the 2 times 22, which is 44. So then when you multiply that out, okay, you end up getting, so go ahead and try plugging that into your calculator to make sure you get the right answer. If not, bring it up to me. I got 752.184. So I look at that third number. I see that it's less than 5, so I do not have to round. I can just cut those off. So I have $752.18. So that is my final answer for number 3. Sorry. Now let's take a look at number 4. So determine amount of the investment if $400, okay, that's my C value, is invested at an interest rate of 4.3%. Well, I need to convert that to a decimal. So I'm going to move that over and I get 0.043. Compounded annually. Annually only means once a year, so our N is equal to 1. For 15 years, that means that our T is going to be 15. So however many years they give us, that typically represents our T value. So we're starting off with $400. So to get our total amount, we need to take 400 times 1 plus 0.043. Again, it says compounded. That's how I know to use the compound interest formula. Divided by 1 time a year, raised to 1 time a year times the number of years. Again, you always want to simplify out your exponent before you punch the whole thing in. You can leave this part as is. And then 1 times 15 is just 15. So once you get that exponent multiplied out, you can actually do the entire problem. So when you do that, you end up getting, oh, you know what? On the previous answer, I gave you the wrong one. You should have gotten for that one 643.63. I was looking at the wrong problem. Sorry about that. For this one now, you should get 752.18. I apologize for that. All right, let's take a look at number 5. So for number 5, we take a look. We have $12,000. That's going to be our C value. Invested at an interest rate of 2.6. Well, we need to convert that into the decimal. So that's going to be 0.026 for our rate. Weekly, there are 52 weeks in a year. That's why our N is going to be 52. For 13 years, that means our T is 13. So let's go ahead and plug that in. So our amount is going to be equal to the fact that we have $12,000 times 1 plus our rate, which is 0.026, divided by our number of times per year, which is 52, raised to the number of times per year times the number of years. So again, before you simplify this out, you should multiply out the exponents. So you get 12,000 times 1 plus 0.026 divided by 52, and that's raised to the 52 times 13. When you multiply all of those out, you end up getting 676. Again, you always want to multiply that exponent first. So now this is ready to be plugged into your calculator. So pause the video. Go ahead and try that. When you plug it into your calculator, you get 16,082.426. We look at that third number, and that third number is 5 or greater, which means this number needs to get rounded up. So our final answer is 16,082.43. Remember, for money, you always use 2 decimal points. For people, you need to round to the nearest person. So that concludes your note video today. Go ahead and show me your completed note sheet when you're done. Thanks for listening.